Hey class, this is Mrs. Gooch again. So today in class we covered the idea of experimental probability. If you don't have these ICANNs in your notes, please pause the video now and write them down, because we will be doing not only finding the experimental probability, but the difference between experimental and theoretical. All right. So experimental probability is probability that is based on an experiment or doing something. So prior to now, we have been thinking about doing stuff. We haven't actually flipped coins, rolled number cubes, or picked marbles out of a bag. But experimental probability is just that. We are talking about those things have happened, and what is that likelihood of that? So again, the notation is very similar. We do have the capital P with the event in parentheses, and then we have the total number of times the event occurs, the favorable event we wanted, divided by the total number of trials. Okay? Again, fractions, you must write them. You must write them in simplest terms, write a decimal and a percentage. So let's try this one. So I'm going to use cubes on this to help me. It reads 13 out of 20 emails in your inbox are junk emails. What is the experimental probability that your email is junk? So I'm going to circle my numbers, just like I do in cubes. And I'm going to box in the words that are important and underline the question. So now, the probability of junk email, how many emails did I have that were junk? I had 13. And then I had out of 20. Okay? So now I type this into my calculator. Can this be simplified? No. So I'm going to write it as my decimal, which is 0.65 or 65%. Okay? All right, let's try another one. The next one asks what is the experimental probability that your next email is not junk? So my event is not junk. Before, we knew 13 out of 20 were junk. So what I'm going to do now is I'm going to say 20 minus 13 gives me 7. That means 7 emails were good emails. So 7 over 20. And that cannot be simplified. But the decimal is 0.35 or 35%. So that is the main difference between theoretical and experimental, is we're actually dealing with what happened. So here's another way of looking at an experimental activity. This bar graph shows that a number cube was rolled 50 times. So if I add each of these columns up, I've got 10 here, I've got 4 here, 8 here, 11 here, and 9 there. If I added all of that up, that would equal 50, okay? Now, what is the experimental probability of rolling an odd? So the question is, what's the experimental probability of rolling an odd? So those are the things I would do for cubes. So now my event is still odd. All right, and we know that the total number of events was 50 because they told us that. But now I need to go in and find out how many odd rolls happened. So I'm going to go to my odd numbers, which are 1, 3, and 5. And I'm going to add up their roll numbers. So I have 10 plus 8 is 18. 8 plus 18 gives me 26. So I now know that 26 is right there. That can be simplified. So 26 over 50 simplified is now 13 over 25. Now I type that as a decimal, and that gives me 0.52 or 52%. Notice again, I am writing everything as a fraction simplified, a decimal, and the percentage. Now, the last question is kind of bringing back to what we did before. How does this compare to the theoretical probability? Well, the theoretical probability of an odd number is, on a number cube, I have 6 options, and 3 are odd. That gives me 1/2, 0.5, and 50%. So I can now say that in the experimental probability, it is higher to roll an odd number on the number cube than the theoretical. Because theoretically, I have an equal number of odd numbers on my number cube as I do my even numbers. All right, class, I hope this helps clarify a few things. Have a great day.